Welcome to From Seed to Sale, Strategic and Tactical Microbe Control for the Commercial Indoor Farmer. My name is Jason Hadley. I am a sales engineer here at Filter Science. We are a manufacturer of air purification, commercial air purification for indoor spaces. However, along with air purification, there just a lot goes into microbe control in cannabis facilities. We wanted to take that time to present you with some of the other interesting facets of what you'll need to know in order to maintain a more controlled environment from a microbial standpoint, which ultimately leads to passing retail compliance testing. So without further ado, we'll get started here. And before we dive in super deep here, let me go ahead and give you a little bit of background around who we are. So Filter is manufactured by Lighthouse Worldwide Solutions. Lighthouse Worldwide Solutions has been around for 35 years. We do R&D, pilot production, services and installation, finance, accounting, quality assurance. We're manufactured out of Medford, Oregon. We do manufacturing, calibration and instrument service, system build out, system service, quality assurance, and product management. Now, of course, Lighthouse Worldwide Solutions, we do put the worldwide in there. We do have our corporate headquarters is located in Fremont, California. We're manufactured out of Medford, Oregon. We have a training center in Arizona, calibration services in Philadelphia, and offices across Southeast Asia and Europe. So some of the areas that we serve specifically are clean room and critical manufacturing environments across semiconductor, pharmaceutical, aerospace, medical device manufacturing, automotive, and of late horticulture as well. Some of our more notable clients, again, most of our business is within the pharma and clean room industry. So we work with a lot of the major players such as Bayer, Merck, J&J, Glaxo, Pfizer, some of the names that you've recognized that are pretty popular today in light of coronavirus vaccines and what have you. So we also service electronics manufacturers as well as defense, including NASA, Apple, Samsung, Raytheon, Intel, etc. And of course, we've moved into indoor agriculture, servicing clients such as Jungle Boys, Tweed, the Cookies family of facilities, Happy Healing Farms, Cannabis, and Suniva out here in Southern California. So let's dive into getting to know the problem a little bit better, shall we? Let's start with some of the basics of microbes. So how big, let's talk about microbe sizes. Microbes are measured in the micron size range. So how big is a micron? So a micron is 1/25,400th of an inch. All right, very, 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 very small. So to give you some average, size comparisons, if you will, the average diameter of a human hair is about 100 microns. We get into like pollen that can be in the 10 to 25, 30 micron range. Animal dander is usually less than 3 microns. Bacteria lives in the half a micron range. So for cannabis, your problems, your plant pathogen problems are typically 1 micron and up. So what does that mean? I mean, you're never going to see it with the naked eye. What does that mean from a size perspective standpoint? So this is the photo on the left is the topography of a human fingerprint, right? If you all look at the tip of your finger, this is what the ridges of your fingerprint look like. With your plant pathogen problems being 1 micron and up, to put that into perspective, it would take 40 1 micron mold spores stacking on top of each other to see over the top of the ridge of your fingerprint. You'd have to have 40 on top of each other. Compared to, say, for instance, the edge of a piece of paper, right? Like just the edge, not even the flat side, not even the flat side. I'm talking about the edge, this part right here. That's what you're looking at the photo on the right. To put that into perspective, if you were standing next to this photo, it would be like a 1 micron particle next to this photo would be like you looking up the Empire State Building from a size perspective standpoint. Okay, that's the level of scale that we're dealing with. In fact, some of the things that are common in cannabis environments, trichomes average about 120 microns. Again, human hairs are 50 to 100. Pollen can be in the 25 to 50 micron range, powdery mildew, roughly 30 to 50 microns. Mold spores actually can go as low as I've seen 2 microns, so we can make an edit there. But at the end of the day, again, very, 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 very small. Bacteria live in the 0.3 to 60 micron range, and viruses, which are quite prevalent these days, are far smaller than that. Fun fact, that fingerprint analogy that I used, would take 2,000 coronavirus particles to stack on top of each other to see over the ridge of your fingerprint. So how small can you see? Under normal light conditions, if like you've just eaten a bowl of carrots and you're in optimum light conditions, the human eye can see about 35 to 45 microns. So what does that look like at scale? Okay, so this is a visual I wanted to present to you again, just to really hammer home what we're talking about and the scale that we're dealing with that can ultimately affect your profitability if you can't get through retail compliance testing. So this is a flea that you're looking at, and I'm going to play this for you. And what you're going to see is you're going to see what's called a diatom on the eye of this flea, but it's not the diatom we're after. The thing that we're after is actually, as we zoom in, that white thing is the diatom, and that pill-shaped thing is the actual thing that you're trying to fight within your facility. Sounds stressful and exacerbating, but it's my job to chill you out here. So I'll again kind of show you another example of this, and know that this problem is definitely able to be tackled. I mean, they deal with this problem in pharmaceutical manufacturing, food manufacturing, any critical area where things need to be absolutely clean in the manufacturing process. So how do some of these pathogens reproduce, right? So on the left, you're going to see Aspergillus niger. This is a mold strain common in cannabis. Some states test for it directly. Other states incorporate it into total yeast and mold count. But in effect, what you're talking about here, let me show you a visual on that. Each one of these stalks has thousands of spores on it. And those spores all break off to be an individual stalk of their own. So when you're in a facility or you're in a critical environment and you see mold, you see visible mold, what you're actually looking at is the reproductive part of it. And where are those mold spores? Those mold spores are continually floating in your air. They're continually floating in your air, which I'll touch on in a moment. So then how does something like a bacteria reproduce? This here is an example of E. coli, and these reproduce by dividing. And you can see over a time lapse here, within a matter of an hour, they have a pretty robust level of, or 2 hours here, you can see they have a pretty robust reproductive rate as well. So these micron-sized particles are hanging in your air. Now, you would think like, oh, well, they'll just fall out of the air. Well, unfortunately, with particles at that size, they're very susceptible to minute winds that and airflow currents that we as humans in some cases can't even perceive. So this is a representation, this chart here is a representation of micron sizes and how long it would take them to fall 1 meter in perfectly still air. So they have a tube, right? And they take a particle of that size, they drop it in the tube. It's not disturbed by any airflow, it's just being affected by gravity. And they time to see how long it takes to fall 1 meter. So in the case of a 1 micron particle, which again is your smallest particle threat, so we're talking about the most extreme size of things, but a 1 micron particle takes 4.7 hours to fall 1 meter in simply still air. Right? Obviously, larger particles will take a lot less time to fall. For instance, 100 micron particles, take less than 2 seconds to fall. And that's great if they fall out of canopy range, they go to the floor, but also do realize that as you're walking through your facility, your footprint, your step within your facility floor is continually kicking this stuff back up into the air. As well, one of the other things that's going on within the traditional cannabis facilities is what's called turbulent airflow. So to give you an idea, let's compare it to unidirectional flow, which is an airflow design that's common in pharmaceutical clean rooms. So within pharmaceutical clean rooms, they set up filter fan units in the panels of their ceilings. They're all HEPA, and they're all blowing air at the exact same rate over the entire expanse of the room. This is called unidirectional airflow. This airflow is coming down all at the same rate, all with the same force, and it's designed to push particles down to the floor, which are then taken up into returns that are at the floor. That air goes up a dead wall space, back up to the top overhead in the dead ceiling space, which then get processed through the fan filter units. This is the idea of continually trying to clean and recycle as much of their own air as possible without having to bring makeup air in. Whereas in cannabis, we're experiencing what are called a turbulent airflow environment. So if you've been to facilities or you manage facilities, you'll see that a common design is to have HVAC ducting that's constantly running through there. You have fans on your ceiling, you have fans on your walls, you have doors that are opening and closing continually. You have people that are reaching into the canopy for de-leafing and other plant maintenance. So there's a lot going on here where particles and mold spores and such can be jostled loose, can either free float in the air until they find a surface that's suitable for them to be able to reproduce, or they can travel out of the room. If your hallway door is open, they can travel that way if you're not negatively pressured. They can latch onto your hands, your clothing, your hair, all sorts of different things, and be carried to other parts of the facility. So now it's not just like viable mold spores that are the problem. I mean, dust is an inherent problem within cannabis facilities as well. Here you see an article from Science Alert from the Research Journal of Environmental Sciences, which states that even inert dust particles, right, non-viable, non-living dust particles, can still have an effect on cannabis plants. Over the top of the plants, these can obscure the top of the leaf, which reduces the amount of photosynthesis that takes place, which can therefore affect the quality of your growth and the size that your plants can get. It can create maybe not necessarily a stress event for your plants, but you're definitely not getting the most out of your plants if you have dust constantly settling and obscuring what are in effect the plant's solar panels in order to produce growth. On the underside of the leaf as well, you do have your stoma that are the lungs of the plant, if you will. At the scale that we're talking about with dusts and mold spores and such, these things can be attracted to the underside of the plant just through mere electrostatic attraction, quite frankly. They don't even necessarily have to land directly into the stoma in order to clog it. They can simply attract and agglomerate over the top of the leaf surface, thus obscuring the plant's ability to breathe. And again, much like with the top of the leaf, you're reducing the growth potential of your plant. So when we're talking about retail compliance, why you may be asking yourself, why is cannabis tested before it goes onto a retail shelf versus lettuce, for example, that is usually not tested until there's a problem, until consumers begin reporting a problem, right? I'm sure you've seen plenty of like romaine lettuce recalls in your time where they pull everything off the shelf because something got through the production process. Well, so food production has a slightly different metric of failure than the cannabis industry. So for instance, in food manufacturing, as well as like pharmaceuticals that are orally administered, like pills, for example, when things are orally ingested, your body has a series of natural filters that are built into it. So you have the acids from your stomach that can break down an impurity. You have your liver that can filter out an impurity. Your intestinal lining can filter out an impurity. Your kidneys as well. So your body has these natural filters that give it a chance to fight off whatever's being introduced to it. Whereas if you take a look at the devil's lettuce, if you will, cannabis is a product that's more oftentimes smoked. So when you're smoking it, you're inhaling particles, right? So these particles are entering your lungs. They're bypassing the body's natural filters, and at small enough rates, these smoke particles can bypass the lung-blood barrier and go straight into your bloodstream, and in effect go straight to your brain as all blood circulates throughout your body. There are plenty of EPA studies and WHO studies that state that particles that are inhaled do have the opportunity to aggregate inside your system, and they are responsible for things like heart attack, stroke, diabetes, a lot of other complications that are due to that. In, say, for instance, a bioterror weapon, the object of the game is to make that particle, like anthrax, for example, as small as possible so that it can be inhaled as deeply into the lungs as possible and therefore have a maximum effect. I know a bit of a gruesome example, but again, we're talking about problems that can be inhaled. One common problem within cannabis is something called aspergillosis, which you can Google. It's some pretty gruesome pictures on the insides of your lungs. You don't want anything to do with it. However, ultimately what that means is that because we're growing effectively fly paper that gets you high, that it's going to attract a lot of problems. And because it's inhaled, it has to go through testing before it hits the retail shelf. The same thing's true of pharmaceuticals, by the way, that are either intravenously introduced or are inhaled, like asthma inhalers, albuterol and such. Those are made under even more stringent conditions than, say, your Tylenols and your Xanax and your Viagras and what have you. So just wanted to give you some context around that. So when it comes to a high-level facility management style, when it comes to a microbe control program, you really ultimately want to take a risk management-based approach. So some of the main sources of contamination within your facility that you're going to want to continually keep an eye on, police, stay on top of, develop programs for, are things like people. People, for instance, are one of the #1 contaminants of cannabis facilities. They bring a lot of problems into, well, let me also stop and say they are your greatest asset, but they can, in fact, at times be a great liability as well. Those who are entering a facility, you don't know where they're coming from. Even if they're coming from their own home, your house is a huge producer of molds that can affect retail compliance in cannabis. So we'll talk about ways to help mitigate that. But other sources of contamination include your processes. Are you creating processes that allow cross-contamination between people and product, or tools and product, and what have you? So your equipment is a source of contamination. This can be where, as you'll see later, poor cleaning practices. I mean, not just the cleaning of the equipment, but sometimes even the equipment itself. Take, for example, shop vacs, which we'll touch on later. That equipment, while well-intended for cleaning up messes, it does have an exhaust, which can blast particles out into your room and thus scatter them further and in different locations for them to find new sources of new hospitable environments for them to root and thrive. The facility itself can be a source of contamination. It's always important to know when you're moving into a facility, if you're not building from the ground up, what was this facility used for prior to you moving in? That can be a really important factor, because sometimes things that processes that take places in buildings, there can be remnants and evidence of this from a microbial standpoint long after the original tenants moved out and you've moved in. This can also be something as basic as wood structure. Mold loves wood, okay? And once mold gets into wood, you have a really hard time getting it out. So one of the other sources of contamination, again, poor cleaning procedures. There is a lot of misconceptions in how cleaning should take place. So we'll touch on some of that a little bit later, but in essence, just kind of know from a high level standpoint that poor cleaning procedures or insufficient cleaning procedures are definitely a case for a source of contamination. And finally, poor training of personnel. So proper onboarding procedures and making sure that you're making things as simple as possible for those that you're training that are coming into your facility, and being able to create a module that will onboard everyone with the same knowledge at the same time. Again, we'll touch on that a little bit later. So how do you determine what some of these sources, or if these sources of contamination are present in your facility? Well, you're not going to know unless you observe your process. You need to watch your process with an eye out for risk management opportunities. You want to observe your employees with the idea of keeping an eye on their behavior, not necessarily to judge them, but to analyze your process and figure out how you can create a cleaner process all the way through, and then implement that, train your employees to do so, and with that, be able to operate cleaner as a whole. So just keep in mind that risk management is an ongoing process. Whether it's the continual discovery of new risks as your processes move along, or continually making sure that current employees, current processes, current equipment, your current facility design is continuing to serve or continuing to be able to, you're managing risks around those. Okay, so again, let's dive a little bit deeper into people as a risk for microbial contamination control. So personal hygiene. Unfortunately, sometimes you wake up late for work, you don't have time to take a shower, you hop in the car and you jam out to work, right? Well, unfortunately, that gives you an opportunity to bring a lot of the problems that are in your home into your facility. For example, Aspergillus fumigatus is a mold that is part of compliance testing in many states, whether it's directly tested for or part of a total yeast and mold count. However, the number one producer of it in your home is your pillow, of all things. Many people wash their pillowcases, but they often don't wash their pillows. And your bedding is a huge source for that, because you're providing the warmth from your body, the sweat and moisture that comes off of you during the night. And as much as this may be news to some of you, that there are smaller microorganisms that are living everywhere. I mean, we're made up of 32 trillion microorganisms, just you and I, just sitting here, right now. So these things are continually transferring from different places, from our couches, from our floors, from our beds. That's not even counting, let's say, for example, if you have a dog, or other pets that do move around the house and infiltrate your bedding. I know how many times people have tried to keep their pets off the bed, but obviously an act of futility as someone who's owned pets myself. But do keep in mind that your pets, and particularly ones that are indoor-outdoor pets, are continually going outside, picking things up between the paws, their fingers on their paws, and bringing them into the house, for example, or things that are latching onto their fur that they're bringing into the house, which then you therefore move about your own home. As well, those that grow at home. Let's talk about that for a second. When you're growing at home, you're bringing in a lot of your home grow problems, potentially, if you have them. We have to assume that those things are there, even if you cannot necessarily visually detect them. These mold spores are ubiquitous. They're everywhere, whether you want them to be or not. So, people who are tending their home grows prior to going to work are, running the risk of bringing the problems within their home facility to their place of work. People that are in poor health, for example. Let's not even talk about coronavirus for a second. Let's talk about just a flu, a cold, right? When your health is not up to standard, people tend to make poor choices, or they cut corners. Or they're continually taking breaks to tend to their own personal health. So if you're not feeling healthy, stay home, okay? People who travel who don't necessarily go directly from home to work. I've seen it countless times where a facility manager will say, hey, can you stop at the hydro store and pick up this and pick up that? Well, things like the hydroponic store, for example, think about how many other growers are coming in there and how many other people's problems are transferring just on the doormat as they walk in. That's not even counting the floor throughout the place. That's not counting the air within the place. That's not counting all of the product that might have been touched or put back up on shelves or taken off of shelves. So if you're going to the hydro store, you do it after work, you go home, shower, you don't go from the hydro store to work. All right, let's avoid that. So process, sometimes one of the processes is failing to properly gown. So the cannabis industry, as part of growing into microbe compliance, is forced to take on a lot of the techniques that are applied in pharmaceutical clean rooms, one of which is gowning, right? What you're basically trying to do, in short, is create a barrier between you and the critical area, okay? So more often than not, as anybody who's might have worked in the gray or traditional markets, you showed up in a pair of shorts and a t-shirt and tennis shoes, and you just went about your business and had a great time because you're growing cannabis and it's a fun job. I get it. Nowadays, however, there's a level of liability that's taking place here that is you're going to get got if you don't apply smart processes. So when it comes to things like gowning, you want to remove your jewelry, your rings, for example. They've done plenty of studies. I've posted them on my Instagram page myself, where they've taken samples from the underside of a ring and found that there's a significant higher portion of bacteria and what have you that are underneath your ring, underneath your watch, for example. I don't wear a watch, but you understand my point. So you want to remove your jewelry. A hairnet is certainly helpful. Again, think of it this way. Again, if Aspergillus fumigatus is produced from your pillow, you may not necessarily be able to get your hands on hairnets that are going to stop mold spores from coming off of your head. But we do shed our hair. It is a natural process. And on those hairs can be mold spores that will then, either root in under habitable conditions or figure out a way to travel. These mold spores are an opportunist. They've been around for 450 million years. They're very good at what they do. And they don't care how good of a grower you are. They don't care about your political affiliation. They don't care if it's your first crop or your 100th crop. They don't care. They're simply opportunists, right? There's no emotion in this process. Continuing on, you want to talk about booties. You want to talk about some sort of foot barrier. Booties are one example. Others do shoe covers. Others do dedicated shoes for the facility that one would change into on site and are cleaned on site. There's a variety of those kinds of options. Gloves, certainly something that you want to, again, create a barrier between your hand and the product itself or whatever process you're engaging in. Face mask is always helpful. We're always expelling respirable particles. Remember, mold spores are prevalent in the air, and yes, we do inhale hundreds of them a day. Not all of them are going deep into our lungs. Some of them are exhaled. You'd be surprised that not just with your scent particles from your breath and your spit particles from your talk, but there are also foreign bodies like mold spores that are continually exiting your body. And then, of course, a smock. The photo you're looking at here is a coverall. It's a little bit more of a head-to-toe style covering. Some facilities opt for more of a lab coat, if you will. Some are going to go with laundered lab coats. Some will go with disposable lab coats. Some will even do Tyvek suits, I've seen, disposable Tyvek suits. So big takeaway from this, you want to create a barrier and just take the precaution and do it. I promise you, it's not going to hurt your process to do that. So let's see, from an equipment standpoint, what are we talking about equipment? All right, let's talk about designated tools, okay? Every room in your facility, you would be well served to have designated tools for every room. In food industries, for example, and other manufacturing environments, they actually specifically purchase color-coded tools so that they know that if they're in the red area and they see blue tools being used, they know to get those blue tools out of there because they should not be in there, because cross-contaminating tools is a huge factor in being able to transfer problems from one side of a facility to another. How many times have you seen somebody running from room to room looking for where they left the broom or looking for where they left their scissors? Okay, so every room should have their own set of dedicated tools that don't leave that room. They should be easily identifiable from across the room. So if a facility manager walks in and sees the room 1 tools being used in room 3, that is just mitigated and handled immediately. Deploying sticky mats is something that's common in pharmaceutical and critical manufacturing. Sticky mats, again, as I mentioned earlier, you pick up a lot of things that are falling to the floor and you're walking through that is churning them back up. Sticky mats are basically the equivalent of a tacky doormat that resides outside the doors of all of your critical areas. And this is something that you would step into by marching in place a couple of times and then move in, with the idea of removing foodborne contaminants from the bottoms of your shoe covers, again, as an extra risk management step to keep from transferring things from your hallways into your flowering or your vegetative or whatever, whatever's going on the other side of that door, okay? For what it's worth, and I don't know that we touch on this here, but Current cannabis facility design is usually involving like a long hallway with all of your rooms kind of stacked along it, versus in Canada or in pharmaceutical facilities, they often take their most critical area and then they build out in concentric circles. So the hallway design is something that is definitely something that we're going to have to evolve into more critical manufacturing environments and the processes that are deployed there. So also creating a touch-free workplace. Creating a touch-free workplace is incredibly important. Anything you can do, again, to reduce risks. They make all sorts of different devices that can, stop you from touching door handles, or ways to be able to deploy hand sanitizer, open doors, those types of things. That hardware is out there. One source as well, covering your trash cans, having trash cans with covers on them. Think about all the things that you throw away within your trash cans. You're throwing away leaf bits, you're throwing away food trash in some areas. Those things will produce molds within your facility, and they will dislodge and they will loosen and they will fly about in different areas and they will transfer to other areas of the facility. It happens all the time. Also, with regard to equipment, dedicated shop vacs. We touched on this for a second earlier. If you're using shop vacs as part of your cleaning process, make sure that every shop vac every room has a dedicated shop vac. I'd even go as far as to say that if you have the ability to have one dedicated for wet and one dedicated for dry, that would be ideal. And also would be ideal, and I know the Rigid is a company that makes these. They make a actual vacuum cleaner bag for shop vacs. They make them at the HEPA level. So including a HEPA shop vac bag within your shop vac would add an extra layer of protection that is going to stop a lot of things from blowing out the exhaust of your shop vacs. So let's move on to the facility itself. Okay, so I walk into a lot of facilities. There are a number of ways to skin this cat. They are built in every type of configuration that you'll ever see, and there are many still that I haven't seen. So some of the things that are kind of unfortunately carryovers from the more illicit market days, where mold control was really more about your craft than about your compliance. Removing exposed wood. If you can't remove that exposed wood, I would heavily epoxy it over. Again, mold is it loves organic material. Okay, as you see here, organic equipment, such as like bamboo stakes, for example. Anybody that's using bamboo in their stakes to hold up their plants, I would very much replace those with something that is a synthetic material. Porous materials are things that you don't want. Anybody that has acoustic tiles within their facilities, you'll want to get that out, even if it's in your hallways or your offices or other areas where you're not actually cultivating or you're not working with product. It would be advised to remove those and replace them with something synthetic, like a vinyl paneling or something like that, because those are made of cardboard or pressed board or some sort of organic material. And as you can see directly below, when they're tied in with the HVAC systems and the ducting, and there's piping that's going into the drop ceiling and what have you, that the opportunity for mold to be created from leakage, for example, from pipe leakage or duct leakage, a huge possibility. Within the facility, you'll want to avoid any kind of cracks in your flooring. If you can seal your flooring, what you're looking for is something that is non-porous and non-shedding. In some cases, they use heat-welded vinyl paneling. Other cases, they will use a heavy epoxy on concrete as well. But again, what you're trying to do is avoid porous materials. If you look at the concrete flooring in your facility at a microscopic scale, it looks like the surface of Mars. There are plenty of things where in plenty of spaces and nooks and crannies where mold spores can take hold and can be picked up by somebody else's shoe or a cartwheel, for example, and taken to another part of the facility. Within the facility as well, anywhere you'd want to round out your corners. In this case, what you're looking at here is what's called coving. This is where you join the floor to the wall. They call it coving, and this is basically reducing the corner This is the opportunity, like any place where there's a 90-degree angle between your floor and your wall, or your floor and your wall, or your ceiling and your wall. These are places where molds can accumulate because they're not often paid attention to as part of the cleaning process, or they're not given the dedication and diligence that they need. So some of the things that can help with that are, for example, air filtration, much like this filter unit you're seeing here. These are things that can help reduce the problems that are just floating in your air. So let's move on to, again, one of the other risks, poor cleaning procedures. So one of the things that's super helpful that I find in cannabis is like kind of an underrated point of knowledge is understanding levels of clean. People conflate the terms sterile with sanitize with clean. They do it all the time, but in fact, these terms actually have very specific meanings. So for example, clean is just simply the removal of dirt, the removal of surface dirt. Whereas you move up to sanitizing, and sanitizing is cleaning something so that the only bacteria or pathogens that are remaining are things that can be handled by the human body. So for example, like sanitizing is something that they would do to like a restaurant table. You know what I mean? When they wipe down the table, that's what they're attempting to do, is sanitize. So now what you're moving up into is the area that cannabis needs to live in, which is disinfecting. And disinfecting is now we're at the point where we're killing not just bacteria, but you're also killing fungi, viruses, and depending on the disinfectant that you're using, spores as well. And then we get into virucides. Disinfectant would be like a sterilant, for example. After disinfection, you get into sterilizing. Sterilizing is the absolute absence of any type of organic viable material on a surface whatsoever. Sterilizing is very difficult to achieve. There's always going to be some sort of residual that's left, whether it's a biofilm or what have you. So when you start to get in, this is where like things like making sure your contact time is adequate. For those of you that may not be aware of contact time is the amount of time that a cleanser needs in order to achieve the level of clean that it advertises on the label. So in some cases, that's 10 minutes. You can find that information on the label of the product. If you go, after this webinar, if you go down under your sink and you pull out a can of Lysol, you would actually be able to see on the back, it says, spray and leave wet for 30 seconds to kill salmonella, or 10 minutes to kill, coronavirus, for example. So that's an important factor to pay attention to, because if you just spray, wipe, you're not giving your cleansers enough time to do the things that it needs to do. One of the ways to also, improve your cleaning processes within your facility is policing all of the fallen leaf bits. I see this constantly where you go and you walk the facility and the tables and the floors just have dead leaves and fallen leaves just sitting all over the place. Mold, think of mold as the great recycler. It's looking for all of these things in order to return them to the earth. Now, granted, it's not going to do that, because you're talking about concrete floors in a facility, but in the forest environment, for example, its whole job is to break down, physical matter down into nutrients so that grasses and trees can reabsorb them and continue to thrive. Well, so these airborne molds are looking for places to land, and fallen leaf bits are, just a bonanza of a food source for them. And then you couple that with, with warm and moist environments, and now you're getting yourself a problem where it's not even affecting the plants, it's affecting the trash of your plant. And however, again, if you remember that one mold spore turns into a stalk, a hypha, if you will, that produces thousands more, and then those release, your replication rate is insidious. And so you're really better served to try to police as much of the dead organic matter within your facility as possible. So now let's get into proper cleaning technique. Again, a lot of people will spray, wipe, wax on, wax off. That happens all the time, right? However, in critical environments, they actually are much more methodical when it comes to their cleaning. So, for example, they're using proper cleaning products and tools, for example, such as mops and wipes, rather than, just sort of, common household cleansers, if you will. There's also a proper technique as well when you're cleaning surfaces. And it's basically an overlapping technique where you'll come down with your first stroke, and then you'll overlap by 20%, and you'll overlap by 20%. and you always want to start from the back and work to the front, or start from the top and work to the bottom. Also, one of the things you're going to want to do is reduce biofilms and choose cleaning products that can reduce biofilms. Some of you may be asking, what are biofilms? I'm about to tell you. So a biofilm is particularly present with regards to bacteria, and a lot of times it happens in places where there's water present. However, what ends up happening is bacteria float along in an environment, or they're carried by the wind onto a surface, and they land on that surface, right? Whether it's water, whether it's an open air surface, what have you. They then attach to that surface. And then in a process that's when enough of them attach together, or they move together to aggregate into one unit, they do something that's called quorum sensing, where bacteria actually talk to each other. And they tell each other, let's start producing this, what's called an extracellular matrix, and basically start to build a protective layer around themselves to shield themselves from the elements, where they're allowed to thrive, reproduce, they have a food source readily available, they're protected from the harshness of the environment that they're in. And eventually, again, through that process of quorum sensing, where they talk to each other, they say, okay, we're getting a little too big for our environment. Let's open it up a little bit. Let's let some of these guys out in order to go find a new home and replicate at another point, either by traveling through your air, or being picked up on your glove and carried to another thing, picked up on a cartwheel, traveled around, or again, in a case of water, floating along within the current of whatever that is, if it's a pipe, a hose, a puddle, what have you. So biofilm, however, can live under the surface of dirt. So when you're performing your cleaning tasks, you want to remove as much surface dirt as you can before you go into your disinfecting phase. I know it sounds like I'm telling you to do double the work, but at the end of the day, if you have problems that are living under dirt, you're not getting them in your first pass. Okay, so you need to do a deep clean before you begin to do a disinfection, and that way you'll get the most out of your disinfectant, and you'll get the most out of your cleaning practices. So now, I'm telling you to get these invisible things that you can't see with your eye. So what actually happens? What actually happens when you clean? What does cleaning actually look like, right? What are you doing to that microbe? So let's take, for example, I'm going to show you. So under a microscope, this is a microscopic photo of, I can't recall the exact pathogen off the top of my head, but this is what happens when bleach hits it. So it's going to take a second here to show you, but okay, so bleach just got hit. The bleach is now hitting that microbe. And what bleach does is tears into the outer protective layer of the microbe. And as you can see here, it's slowly dissolving and breaking up the membrane. And basically the microbe is bleeding out from the inside and then dissolves away. Okay, so that I just wanted you to visualize that, because every time you spray something, I'm like, what am I even doing? I don't know. This is what you're doing. And different cleansers like alcohols and bleaches and quaternaries and such like that. There's lots of different classifications of cleansers, and they all do all sorts of medieval stuff to these microbes. But I wanted you to be able to internalize, this is exactly what you're doing to your microbes. You're not like wiping them away and they're carried off on your rag. You're actually trying to physically destroy them. Okay. So when choosing cleaning products, match the product to the pathogen. You want to be able to know that the thing that you're killing is actually being killed by the product you're using. That makes a lot of sense, no? So understanding the mode of action, understanding what that cleanser is actually doing. Because again, some of them do different things. Some of them break down a membrane. Some of them disrupt cellular activity within, and that's stuff that can be easily researched. You want to use, again, remember to use proper contact time. You also, of course, want to learn if it conflicts with another product you're using. And I'm sure plenty of times you've heard to never mix bleaches with ammonias, right? You end up creating a gas that's toxic, right? And that's standard that's happened in household environments. So odds are, with all the other variety of cleansers that you're using in these facilities, understanding if there's a product that will conflict with it and create a problem is key. It also wouldn't hurt to have a rotation program where you're rotating your cleansers maybe every fiscal quarter or something like that. This is to help lower the bioresistance that can sometimes build up. It's been known to happen If you take, for example, spider mites, which are an insect in cannabis, that you have to attack it with multiple things in multiple different directions, and it can build up a resistance, and that resistance can be passed off to its offspring. So same thing can kind of happen in some cases with particular cleansers and microbes. So also know the safety, cleanup, and use instructions. Okay, some of this cleaning stuff that you're using will require certain safety equipment like gloves or eye masks or masks or eye protection. What have you. What happens if you spill it? What happens? How do you clean it up? You want to make sure that you're not using something that's going to create a bigger problem and you're trying to clean up something that you spilled. And you also want to understand the instructions and knowing like what are the dilution rates? How do I actually use this thing? Because if you're using something at full strength and you're not supposed to, you can create problems. And likewise, if you're not using it at the proper strength, then you're not getting the most out of your disinfection. So then you'll always, of course, want to document when and how you did the work. Keep a running record of things that are going on within the facility. That way you can easily look at a glance and you can say, oh, yeah, this cleaning was done and the checklist was followed and everything's running. The procedure is operating as intended. It never hurts to, of course, open a commercial account. I mean, there's, the cannabis industry does have plenty of products that are sufficient for taking care of cannabis specific problems. However, there are also commercial janitorial suppliers for pharmaceutical industries, for hospital industries, clinical environments. And these guys have a variety of options as well. And their whole job is to help you by, you can just simply hand them a list and say, these are the things I don't want in my facility. What are the cleaning agents that can get rid of this? And it's their job to help walk you through it, make sure you know safety procedures, make sure you know how to use it, etc. So let's move on. Where's my mouse? There it is. Okay, so poor training of personnel, also a factor. So standard operating procedures, these are important. These are critical to your environment. You want to make sure that the process is being adhered to, that it's the same process being adhered to, that you're recording that it's done. And if changes need to be made, those changes are made and updated and revised. SOPs are huge, okay? We actually have an SOP webinar as well. So we'll make sure that you guys get information on that going forward. So also training and cultivating talent, okay? How you train your employees is critical. You ideally want everybody onboarded on the same track. You want the person who's been there a week to know the same amount of material that's been there for a year. Okay, so if you're training and you're onboarding people properly, they can get right out into the workspace, get right to work, and you're not having to worry about policing them as much. As well, keeping your tools sharp, competency testing, being able to, as a facility operator, go to your employees and say every 6 months or so, hey, we want to just make sure that you're up to speed on the current practices and then you know what's going on. And there's the competency testing is huge, and it's a very, very common thing in pharma. So let's see. So you have a microbe problem. Now what? You need to determine the root cause. Okay. This is a fishbone diagram that you see here. This is a way to kind of help narrow down factors that take place within your facility. In this case, it's, you want to look at the materials that you're using, the methods that you're using, the measurements you're taking, the machines, the environment, the personnel. These are all of the things that can contribute to the cause of a problem. However, you want to be able to organize that. Otherwise, you're just kind of shooting into the air, all right? So if you have a problem, you want to start with these 4 questions. Where is it? You need to be able to test for this. How can you test for it? You can do passive air sampling, where you just set a Petri dish out. You can do active air plating, where you use a machine to draw a measured amount of air onto a Petri dish. Again, you send that to a lab. You can do contact plating, which is a Petri dish where the agar goes all the way up to the top and you can press it onto a surface, and then you can send that off to a lab for analysis. There's surface sampling, there's lift tape sampling. So in other words, you need to be able to find out where in this facility your problem is and where it isn't. So you know what areas to quarantine, you know what areas are safe, you can adjust your staff and your traffic patterns accordingly. So with regard to testing locations, anywhere where people come in contact with product is foremost. This would include floors and tables and walls, fans, vent covers, tools, equipment, entry points, hallways, gowning areas, what have you, okay? There's a lot of places that you can test. And, many of these facilities already have all sorts of information that's coming in with regards to temperature, humidity, CO2, all the factors that go into flowering, and you have whole monitoring systems around this, it would make absolute perfect sense to know what the microbe counts are in various areas of your facility, and even be able to predict where a problem may lurk, where a problem may lurk. So as far as testing suggestions are concerned, partner with a lab that serves food and pharma industries, because they're used to highly regulated industries. If they sell supplies, use theirs. They're fresh. They already know how to test with them. It's way more convenient, I'll tell you that, than trying to source your own products from like Amazon and stuff like that. You'll want to make sure that the lab has an on-staff mycologist. This is somebody whose whole job is to speciate mold. You want to make sure that they can test for the pathogens that you're being held to compliance to. So, you can give them a list of the pathogens that you're concerned about, and they should be able to tell you whether or not they can test for them. Some of them will come back with a total yeast and mold count. However, a total yeast and mold count will factor in beneficials and as well as compliance pathogens. So it's not really an accurate description of what's going on within the facility. You want to test early in the week and deliver. Okay, so when you're doing your testing, try to do your testing in the early part of the week, because you got to ship this off. If there's a problem with FedEx or whatever, you don't want this stuff landing on their doorstep on Friday afternoon, because it might not go into an incubator until after the weekend, which then adulterates your sample. So question 2, how did it enter, right? Did it enter on tainted genetics? Did it enter through tainted media? You have the right, nay, I say the duty, to test these things that are coming into your laboratory or your facility, whether it's a laboratory or whether it's a cultivation facility, an extraction facility, what have you. You have the right to test the incoming material. You also want to look to see if you have any neighboring businesses that may be a problem, like breweries, bakeries, cereal factories, even other cultivation centers. You want to potentially know, how did it enter through auditors and visitors? Back in the day, it used to be, don't let people in because you didn't want to get your stuff stolen, or you didn't want to get busted by the cops. Nowadays we have auditors and visitors that are coming into these facilities, whether they're investors or what have you, and they need to be treated as a threat to the microbial environment, okay, or the environment at a microbial scale. Also landscaping, exterior landscaping, and you want to avoid employees that work on multiple sites. So how does this, question 3, how does this problem thrive? Is it thriving on dirty tools? Are you having floods and you have standing water and the problems that are produced from flooding? Are you transferring it from commonly touched surfaces? And then finally, how is it traveling? Is it traveling in your facility corridors? Is it traveling through your HVAC? Are you cross-contaminating tools, right? So what's the fix besides burn it all to the ground, right? Fix number 1, facility redesigns and retrofits. Epoxying over and removing wood and organic material, positive pressuring. If particles can't blow into a room, then they're not as much of a threat. Again, replacing synthetic and porous and shedding materials with synthetic and non-shedding materials. You want to foolproof the facility as well. I mean, self-closing doors are huge. You'd be surprised how many people leave the door open, and that allows for a lot of transfer between your hall and your critical areas. Also, linear foot traffic, making sure that you're scheduling your employees so that they're not constantly bouncing between rooms. If they do have to bounce between rooms, there should be some sort of mitigation point where they don't cross-contaminate between rooms. Fix number 2, diagnostics and testing and remediation equipment. Particle counting, huge. This is how clean rooms maintain their clean room levels, is they count the particles in the air. We manufacture particle counters. Supplemental air filtration, as I mentioned, filter, right? Filter, get one today. This is going to help continually remove particles from your air, right? Again, a lot of your problems are present in your air. As well, microbe sampling, like we talked about before, being able to get a picture of not just like how many people are at the party, but who are they by name, okay? If you don't know that information, you can't adjust your cleaning protocols accordingly. Fix number 3, cultural practices, just the basics, proper hand washing. There is a proper hand washing technique. It exists, that's it. Documenting everything you do so that you know that all of your steps are accomplished. SOP reminder signage. There's plenty of signage from other industrial manufacturing processes that you can apply and hang around your facility to continually keep the seed planted, keep a reminder in the heads of your employees. And finally, these are some things that you're going to want to get to know as you go forward in evolving your microbe control program. Okay, so in current pharmaceutical, food manufacturing, critical environments, they operate and apply what's called CGMP, or current good manufacturing processes. This is a whole set of standards that you can apply to your facility in order to operate cleaner from the start, and ways to continue to operate cleaner. Also something called HACCP, which is Hazard Analysis Critical Control Point. This is the ability to take your facility and really analyze where the hazards and risks in your facility are in order to mitigate those threats and be ahead of those threats. And finally, something called CAPA. CAPA, Corrective Action, Preventative Action. These are protocols that you can use to prevent accidents from happening, and then have a set of standards and procedures in place for when something does happen. Okay, those are things to start familiarizing yourself. They're totally Googleable. There's lots of information on them out there on the web. So to summarize, the benefits of cleaner operations: crop protection against foreign materials like bugs and mold and biocontamination. You can potentially increase your yields from these things, because if you're not having dudding plants and plants that have to be ripped out in the middle of the cycle, that's lost revenue to you. So you want to be able to get the most out of these plants. You're trying to run them in the red with nutrients and light and what have you. You're trying to just get that 3 a light or whatever it is you're going for. Increase your yields. Okay, operate cleaner. Possible reduction in pesticide and fungicide use. If you're operating cleaner, you don't have to throw as much junk at your plants. You know what I mean? That the stuff that they don't use that can potentially cause harm. You have reproducible product results. Okay, everybody's looking for a template. McDonald's doesn't sell hamburgers; they sell a template. That's why I have a Big Mac tastes the same in Kansas City as it does in Dubai. Right? They sell a process. You're making safer medicine for your customers, and you're creating happier customers, and happier customers are loyal customers, and loyal customers translate to profits. Right? Isn't that why we do this? So with that said, I do want to take a couple of questions since we have a couple minutes here. One of the questions that did come up here is, why is 70% isopropyl alcohol better than 90%? Good question. All right, so what is that other 10% or 30%? It's water, right? So if you remember, we were going back to the concept of contact time. The longer the amount of time a cleanser can stay in contact with the surface and the things that it's trying to kill, the better. So while 90% might be great for cleaning glass surfaces and what have you, like your glasses or whatever, 70% is used. It has more water in it, which allows more time to prevent evaporation and allow more time to denature the microbes that are present. All right. So if you're choosing out isopropyl alcohol, definitely want to go with 70% over 90%. Also, let's see here. Can I just install UV in my rooms? You can, but it's not going to be effective. I mean, UV is a great technology. UV is an amazing technology. I would just posit and argue that it's not effective in cannabis by virtue of the fact that it's a very passive technology and you have to be within a certain distance of the UV. UV devices can oftentimes produce ozone. So there's a variety of things that are going on with that, and you don't maintain contact times with UV. Like, how much UV should you be holding over a surface, and what's the distance of that surface? There's a lot of unknowns compared to something like a HEPA air filter. HEPA is a standard across pharmaceutical. It's across the FDA compliance. It's across USP 797. HEPA. Okay, just trust me on this one. You've ridden with me on this ride this far. Trust me, HEPA. How long can you use a sticky mat before tearing it off for the one underneath? They typically come in sheets of 30. There's 30 sheets underneath, right? And when you're pulling them, you want to pull from the corners into the middle because you don't want to jostle and loosen particles. I would suggest once a day, right? You got 30 of them there, so you're replacing that sticky mat on average about once a month. Also, when you're talking about sticky mats, let's talk about, since I have a quick minute here before we sign off, some people orient their sticky mats like a doormat, right? What you really want to do is orient your sticky mat more vertically, if you will, to account for stuff like people stride, because oftentimes they won't march in place before they walk in. They'll just stride over. as well. You also want to factor in for the travel of a cartwheel as well. Remember, a 6-inch cartwheel, actually the circumference of that is about 19 inches, 20 inches. Okay, I won't do the math here now, but it's around there. So that being said, when you're factoring for sticky mats, orient them vertically, march in place, and yeah, use sticky mats. Just trust me about that. When I think about foot baths, I think foot baths are great. Foot baths, are basically a trough that one would step in. Clearly not something you want to wear open-toed shoes in your facility around. So that said, I would use foot baths. You just have to basically make sure that somebody's continually filling it out, filling it up with whatever chemical you're used to cleaning it, and that you're not tracking that water and that dirt. You want to prevent a slip and fall situation by having something on the back end to kind of help pad you off and dry the bottoms of your feet off as you walk in. And finally, one last question: should we use scrubs or disposable suits? Really, at the end of the day, it's on you. Different processes call for different things. You also have to factor in for employees and culture shock. And, all of a sudden going from street clothes to, clean room bunny suits is cray, right? So, there's a lot of factors that go into that, but at the end of the day, use what's right for you. And they all have their pros and cons, when it comes to cost or trash production or what have you. So before we go, the webinar, we're done here. I do absolutely thank you for your time. We do have a survey that's going to pop up in a separate window. So if you can take a couple of minutes and fill out that survey, that'd be super helpful. And also just really quick, again, don't forget to take our survey, and we'll be sending you an invite for our next webinar in November, where we'll be touching on the topics of the basics of building standard operating procedures. So that's been my time. You guys have been amazing. Thank you very much for sticking through this and learning more about high-level facility microbe control. My name is Jason Hadley. My contact information is on the screen. If you have questions about filter or about microbe control in general within your cannabis facility, please don't hesitate to reach out. I'm always happy to answer questions. And the problem is bigger than a magic box you put in. It's a process, but it's learnable. All right. So stay safe out there, guys. Thank you very much. Have a great day.